All right, Algebra 2, here we go. Law of sines. This is going to be a two-part series, so I'm just going to get you guys some basics going for the first lesson here. So we'll call this 12.4 Law of Sines, Part A. We're going to focus on finding the area of a triangle using two sides and an included angle. And then we're going to start using the law of sines to solve triangles. So here we go. One of the first things we got to cover is when you see capital letters, know that the capital letters is representing angles. So if it says capital A, for instance, it's not side length A, it's the angle A. Lowercase letters are going to be representing the sides. Okay, so the area of the triangle here, and then, this is already a typo here because that should be a lowercase, but the area of a triangle is base times height, right? So it's going to be small b times height divided by 2. All right, so that's a review back from geometry. And so today we're going to really focus on trying to find out what h might be. If they don't give us the height, how can we find it using some trig tools that we've learned? So let's take a look here. It says here, think if you knew the measure of angle A. So we could just like throw something in there. Say it's 30 degrees. And the value of side C here, so if the value of side C was, let's just say 10, could you find H? All right, so, and then it says how there. Well, if you think about that, if this is your perspective here, 30, the H piece is opposite on this right triangle that they've created here, and then the AB length is actually the hypotenuse. So what trig function deals with opposite and hypotenuse? And hopefully you know that the answer to that is sine, right? SOHCAHTOA. So we could say the sine of 30 degrees is equal to h over 10 and solve for h, right? So that's kind of what, that's going to be what we're doing here. Sorry for the woodpeckers in the background, but I am teaching outside. Example 1 here says, find the area of ABC. I've drawn it for you. You should draw the picture as well in your notes. To the nearest tenth, if A is 31 degrees, B is 18 meters, and C is 22 meters. So I drew the picture out there. And know this too, a refresher from geometry, that side length B will always be across from angle B, right? And side length C will always be across from angle C. So when you see that lowercase b, I want you to recognize that that is straight across from angle B, right? So 18 is straight across from angle B because that is side length B. So you represent it, the side length, straight across from the angle, the same angle of that, using the same letter, just one's uppercase, one's lowercase. All right, just so you know, if you don't remember that from geometry. Okay, so here we go. We're going to find the area of ABC. We know the base looks like. We need to find the height. So how do I find this height here? That's what I'm looking for. Well, it's that same question I just posed, but the problem is here that one thing that I've seen students try to do is try to use this 18. All right, we don't want to use the 18 here. What I want to do is use this guy, this relationship, and this piece. So if I do that, I know that the sine of 31 degrees is equal to h opposite over hypotenuse, which is 22. Okay, so you could finish this up here. So h would be equal to 22 multiplied by the sine of 31 degrees. And then you could find your h value. Let me just run this calculation really quick here. So I'm going to pull out a calculator. You should be doing the same. So if you just make sure you could get this, make sure your calculator is set to degree mode. So if you take the sine of 31 degrees, you should get 0.51-ish, and then you multiply that by 22, and you get 11.33. Okay, so your height is 11.33. Then I would keep that in your calculator, multiply that by the base, which in this case is 18. And so when you do that out, that 11.33 times 18, that's base times height, and you divide it by 2, you should get 203.95-ish or 96-ish divided by 2. I'd keep it in the calculator again. When you divide by 2, you should be getting 101.98, and that would be in meters. So there you go. There's the area for example 1. The second thing we're going to do here is the law of sines. So the law of sines simply states that the sine of any angle over its opposite side is equal to the sine of any other angle over its opposite side. All right, so let's work that a little bit here. So notice here, sine A over A is equal to sine B over B, etc., etc., right? So make sure that's in your notes. Let's just do one. So example 2 says, we have triangle PQN here. Okay, and I've drawn out the things that we know. We know that N is, we don't know what N is, but we know what P is, we know what Q is. We can find N. So to find N, since I know that every triangle is made up of 180 degrees, I could take 180 degrees and subtract 65 and subtract 42. So when I do that, pulling out a calculator here, so we have 180 minus 65 minus 42, we get 73. Okay, so this would be 73 degrees, and that's how I know that. All right, once I know that, I can use my law of sines because I have this angle-side relationship. So I can say the sine of 73 is over 5 is equal to the sine of, say, 65 over lowercase q. How do I solve this? Well, this is equal here, so I can use cross multiplication. Okay, so I can say 5 times the sine of 65 is equal to q times the sine of 73, which means q must be equal to 5 times sine of 65 divided by sine of 73. All right, so then I would go ahead and put that into my calculator. So I have the 65 times sine, multiply that by 5, and it's approximately 4.53, and then I'm going to divide that by the sine of 73 degrees, and I get that q is equal to 4.73-ish. All right, so notice here, you can kind of check yourself, and I apologize for the construction noises. You can kind of check yourself here because you know that across from the 73 degree angle you have 5. This angle's smaller, therefore this should be a little bit less than 5, which it is. So I'm kind of like doing a mental check to see if I did my math right. What I want you to do is finish example 2. So what I want you to do is figure out what the other side length would be. So to do that, you would use, you could go back to sine of 73. Sine of 73 over 5, and set that equal to the sine of 42 over p, right? And do the same thing and find out what this value right here is, this p value. All right, so I'll leave you with that, and then that'll be the end of this lesson. We'll pick up the ambiguous case of the law of sines next time. Thanks, guys.